Now if you remember our lecture from last week, we had discussed the Carnot cycle, wherein we had discussed this PV diagram of a Carnot cycle. So we had isothermal expansion, reversible adiabatic expansion, isothermal compression, and reversible adiabatic compression. Now you can notice that instead of calling it reversible adiabatic, we can also call it as isentropic, because isentropic means nothing but a process which is adiabatic as well as reversible. And if you remember, the first important point about Carnot cycle was that the entire cycle is reversible. So anyways, this is the PV diagram for it. This is the input of the heat that enters the system, and this is the heat that leaves out of the system. And somewhere here we do a work. The system does work that can be utilized further. Right. So this is a TS diagram of the same thing, that is temperature entropy diagram. So 1 to 2 was isothermal expansion. Since it is an isothermal process, the temperature remains constant in 1 to 2 process. As for 2 to 3, since it's an isentropic process, the entropy line remains constant. So 1 to 2 and 3 to 4 are isothermal expansion and compression respectively, and 2 to 3 and 4 to 1 are isentropic expansion and compression respectively. You can see how the temperature entropy as well as the pressure volume changes throughout the cycle. And based on this, we'll do whatever numericals that we are given in the exam or that we encounter anywhere. Alright, so let's get on with the numerical.